Good evening, students. Today I am going to conduct some topics of electric charges and fields orally. First of all, we have to know about the charge. What is charge? Charge is the fundamental property of matter by virtue of which it experiences an electrostatic force when it is placed in the electromagnetic wave, or an electromagnetic wave is applied across the matter, then it experiences electrostatic force. This is the property. This fundamental property of matter is called charge. There are two types of charges: positive charge and negative charge. One electron carries 1 unit negative charge. Its value is 1.6 into 10 to the power minus 19 coulomb, and one proton carries 1 unit positive charge. Its value is same, 1.6 into 10 to the power minus 19 coulomb. Property of charges: same charges repel each other, opposite charges attract each other. Third property of charge is quantization of charge. The charge contained by any body is equal to the integral multiple of charge of electron. If a small q is the charge contained by the body, then q equal to plus minus a small n into a small e, where a small n equal to 1, 2, 3 and so on. Next property, conservation of charge. For an total charge of an isolated system is always conserved. For example, let us take two neutral bodies. Then the total charge of the two neutral bodies equal to 0 when these two bodies are rubbed with each other. And if let us suppose that two electrons jump from the first body to second body, then 2 unit positive charge appears on the first body and 2 unit negative charge appears on the second body. Therefore, total charge after rubbing equal to plus 2e plus in the bracket minus 2e equal to 0. Here we see that total charge before rubbing equal to total charge after rubbing. Hence, it is proved that total charge of an isolated system is always conserved. Then the next property is conservation of charge, and next property is additive nature of charge. It means total charge of an it means charges can be added algebraically. Charge is a scalar quantity and charges can be added algebraically. That is q equal to q1 plus q2 plus q3 plus and so on qn. Invariant nature of charge. It means during motion the magnitude of charge does not change. Charge का magnitude change नहीं होता है. These are the properties of charges. Now, charging of the neutral bodies. There are three ways. There are three methods by which we can charge the neutral body: charging by friction, charging by induction, and charging by conduction. What do you mean by charging by friction? When two bodies are rubbed with each other, then due to friction, some electrons jump from one body to another body. Then the first body acquires positive charge and second body acquires negative charge. In the method of induction, when a charged body is brought near the neutral body, then neutral body also gets charged, but in opposite nature. This method of charging is called charging by induction. Charging by conduction. In this method, when charged body is brought in contact with the neutral body, then the neutral body also gets charged, but in the same nature. This method of charging is called charging by conduction. Now, we have to explain Coulomb's law. What is Coulomb's law? Coulomb's law is the important topic of electric charges and fields. Coulomb's law states that the force of attraction or repulsion between two charges is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. Let us suppose that there are two charges q1 and q2 separated at a distance small r. Then the force of attraction or repulsion between two charges F is directly proportional to q1 q2 and F proportional to 1 by r square. If we combine above two factors, then we get F proportional to q1 q2 by r square, or F equal to k q1 q2 by r square, where k is constant of proportionality and k, its value is k equal to 1 by 4 by epsilon naught. Epsilon naught equal to 8.854 into 10 to the power minus 12 coulomb square by Newton meter square. Then if we put the value of 4 pi and epsilon naught, then we get the value of K equal to 9 into 10 to the power 9 Newton meter square by Coulomb square. Therefore, F equal to 9 into 10 to the power 9 Q1 Q2 by R square. This is the Newton, this is the Coulomb's law. Coulomb's law, and by Coulomb's law we can we can calculate the force between two charges if the values are given. Q1 is given, Q2 is given, R is given, and we can put the value of 1 by 4 epsilon naught. After putting the values, we can find the value of electrostatic force between two charges. This is the important topic. Electric force is, you know that force is the vector quantity, therefore electric force is also the vector quantity. Superposition of charges, superposition of electric forces. If there are many charges, there are a large number of charges Q1, Q2, Q3 situated in different parts and different locations, then the net charge on net force on the given charge is equal to the vector sum of all the forces acting on this body. This is known as superposition principle of electric forces. Thank you.